here. So we're going to get into a little bit more details about the common data elements here. Okay, I guess we have this animated. So together with the spinal cord injury group, we decided to simplify the working definition of common data elements. And that's what we have up here. You're going to find lots of different ones in different places. So this is what we have here, just standardized variables. So basically, it's what you're already collecting, like the injury model, some of these things that were just mentioned: strain, age, time after injury, and so on. So we want to keep in mind too, like the goal here is it's not just about the CDEs, but the goal is to promote just consistent data collection and data sharing. So that's ultimately well, that's one of the goals. I shouldn't say ultimately. Data sharing is one of the goals. And then, of course, we want to make sure we're looking at what's possible once we have shared our data and once people download it and are comparing and combining data sets and things like that. So then we have the question here is why are we doing this? It's not just because NIH wants us to share their data or is mandating us to share data, but it's ultimately then it's going to facilitate translation. And I know that is a cliche. We all put that into our proposals, right? We want to improve translation because we have such poor translation in TBI. But I think the thing to keep in mind here is it's not something that, okay, you're going to start using CDEs and all of a sudden, like your results are going to start translating, right? So this is just one critical step so that we can all talk the same language. We can better execute multi-lab studies and more multi-lab preclinical studies, and then also just post hoc analysis of combining different data. So we also are trying, we're going to keep in mind here, there's some talk about, okay, do we need to map the clinical data elements onto the preclinical space? And this is something that receives a lot of attention. We think it's very important that we capture certain things that are, obviously clinically relevant, but that are the same concept between clinical data that's collected and preclinical data that's collected. And ultimately, if you say, okay, well, you're talking about translatability, then of course you want them to map. But the truth is it's just hard. Sometimes it's hard to focus this, right? So, there's not a Morse-Water maze equivalent in the clinic, right? But there's certain cognitive constructs that are the same, right? So maybe there's something that can be captured there, but then some of the details about how you conducted your water maze might be just in the preclinical. And that's an oversimplified example, but it is important because there's, even age isn't necessarily the same thing. Is it the age of the injury? Is it the age of, when you're doing this assessment or whatnot? And by producing this lexicon, then, ultimately we want to improve not just the translatability, but the rigor, the reproducibility, the transparency. So in accordance with the FAIR principles. Also, one thing that we were talking about at this morning at a table was this lexicon issue and this ontology issue, and that's something that common data elements is not the same thing as an ontology. I know Monique and others are working on ontologies for TBI, and this is very important. So that it's just semantically mapped. So common data elements will help with that process, but it doesn't replace that process. So we wanted to stop and ask a question here. Why do you think we should be developing CDEs? Or if you don't think, I assume because you're here, you think that we should, but if we have any skeptics, you're welcome to speak that too. Okay. You have no choice as the PI to use common data. She's the PI. So, okay, so let's suppose that you get resistance in your lab that they don't want to use CDEs because it is hard. It's like an extra blade of work. They might say this is not what you hired me to do, or whatever. So I think the investment can be made in terms of time now, and then future experiments will be easier to do. So I guess there's a couple things that you could say to your lab. Is not just you have to do this, but that, if you set these things up, you might identify things that you should have been collecting that you'll need later that you didn't collect because you didn't kind of think about this a priori when you did your study design. And then also that once you have your study design and you've pulled out the data elements that you will be using, it's sort of set up for you later. And it also allows for, from student to student, postdoc to postdoc, for there to be some continuity in what you collect, because none of us really want to admit that, but it happens to all of us, right? Where you're looking at somebody's data and then you're sitting with you're sitting with somebody else who's supposed to have emulated that study design, and they're doing things differently. So this will also help consistency within the lab. Yes.
So I'm in a lab where I'm the only person on the TBI, and it's hard for me to draw trend and negative outcomes. So for example, like I do CCI, but sometimes my mind's just dying. So like the injury is exactly the same as others, or maybe even less. But I don't have enough data to make a conclusion if it's based on the weight. If maybe if I have 3 examples, fine. But I'm sure with something like this, I'm really interested because maybe other people might deal with something similar, and we should make larger conclusions.
Yeah, no, that's a really interesting use case, I think. And I have to say, I haven't thought about it before, but when you have, yeah, I suppose we could be sharing data, not just for like, it's going to be the publication part, but it's going to be when you're trying to troubleshoot something, right? If people were willing and it became more commonplace to share the failures, right? And that's happened to me before. Like they come, they say the rats are dying. Well, why are they dying? I don't know. I did everything exactly the same. Okay, well, did we collect the data that we needed to even start to figure that out, or we just, wait for the next week? So that's interesting. If there could be some kind of repository for problems, if you will, because that would be nice. Anthony, and then
So which one do you all enjoy doing more? Planning your experiments or doing them?
is this a trick question? Doing them?
Yeah. I mean, I'm curious because, so much of what we do is on the program side is really, designing things from the top down and doing the planning. And then the doing later on actually becomes, just sort of, a muscle motion. So in my mind, what I'd love to see you guys do is have more time for planning these things, more time for planning these things across different laboratories and spending less time actually doing it, because that saves money. It uses less animals. And so, I mean, this is one thing I can see. Plus, you'd all have time to write more applications, right? So you get more money out of this. So there's some cost effectiveness out of this, but I see this as a planning tool in a lot of ways. And I just really want to understand, how you would use this to actually implement better ways to do this without, also putting pressure on people that aren't so familiar with it, that they're going to feel like they're going to be micromanaged. As a matter of fact, I'm going to tell you a funny story. This gentleman sitting right next to me. So this is Dr. Newmeyer. He's one of our VA investigators. So he just got a recent award with us, right? So, doing the program manager stuff, I wrote him 2 nasty grams. And one was, complaining about the labor. But the other one was, talking about putting his data into PRECISE. And so he gets on the phone with me and, webcast, whatever you want to call it, starting to show my age. But he gets on there and we start chatting. He's like, "What's PRECISE?" I said, "Why don't you come down and find out?" So, that's the other thing, is getting people to adopt this. But so much of this is literally just planning things. And what I've discovered is a lot of times when your experiments aren't succeeding, it's because, you know, you take a step back and, you know, not spend so much pressure on performing, but actually sit back and look at why you failed. So,
Measure twice, cut once.
yeah, with a sledgehammer.
They can't hear it on the recording if you don't use the mic. Get it together, Russell.
No, I just to this point, which I've been thinking a lot about this morning, because so we had a meeting this morning to talk with spinal cord injury folks about whether we want to do similar preclinical CDEs, and we had a fantastic talk from one of our clinical coordinators from here at UCSF, from the Zuckerberg General Hospital, who is in doing clinical research, and of course she's using clinical CDEs. And Neil actually asked a really great question. Asked her, how much time are you spending in the course of your day dealing with CDEs? And she said, well, none really, because we did that at the beginning, right? If we start to, it's sort of a culture shift, but if we start to, I think to your point, if we start to think more about our preclinical studies as being somewhat like pre-registered, and having, especially having these CDEs going forward, so that we can sit down and plan them first, and it becomes much easier. We're going to talk a little bit about mapping our data to CDEs later, and it takes a little bit of work, but if you start from that top-down perspective and plan your experiments accordingly first with the CDEs, it goes a lot smoother.
Ramesh? Yeah, we have
Yeah.
to get a
So
quick-
to sort of go back to the comment that that lady made over there, in my mind, for me, the way I find this is useful, and I've been collecting data for a good number of years, there's a drift, right? As my devices get older, you know, the way the outcomes, the acute outcomes in terms of, like, let's say apnea or writing reflex or something like that, that I used to get with the same age animal, the same parameters of injury in 2005 is not what I get in 2024, right? And part of it could be the user, part of it could be just the devices. You know, there's some wear and tear to the device, and especially if you get new devices somewhere in the middle. So for me, I find it useful is I can go back and say, you know, when I generated data for paper that was published in 2010 versus the paper that I'm submitting now, it's the same injury model and the same species, the same kind of, but it's a different experiment. It's helpful for me to know how much things have changed, and hopefully it's not a whole lot, but it is what it is, right?
Right, and you'll have that documented, and we're going to talk about data management and also the models catalog, which would help with that as well. Okay, so I won't go over this. This is just a quote from the NIH website about it. This does help meet the data sharing guidelines, but they're not. Oh, Stu, you can interrupt this.
Well, it's while we're on the data question, how much data detail is enough? I mean, is it just pulse ox at time of injury or temperature at injury? Is it the lot of rat chow that during that time of the study? Is it the animal care person and what time they came into the room to change the litter and how they do it compared to someone else? I mean, how deep in the data is, I mean, yeah, I was thinking about anesthesia. Is the anesthesia that lady was, I'm sorry, I don't remember your name. My apologies. And Laura, the anesthesia that you use, how does it compare to someone else? Maybe it's even that lot of anesthesia, or maybe those parvovirus that the Sentinel in the animal facility didn't pick up and had a respiratory issue that you did not know about. I mean, how, yeah.
This is a really good question. It's one I think we're going to struggle with for a while. We need to let the community decide that.
Yeah.
Precise in the VA, we're not going to, NIH is not going to say how much, because we can just CDE everything, right? And you're never going to get to that point where you're actually figuring out the problem if you're just, so there has to be a balance. But it's a good point to think about. Okay, we're gonna save your question now because we're gonna move on. We'll have some time for questions, but they're not required. So that's the second point to that side. But I want to move on and let Neil take over and talk a little bit more about the FAIR principles and some of the management strategies.
Right, so the FAIR principles are related but independent and separable, and are a set of principles and guidelines to manage the data and for agile stewardship. So CDEs, they really embody all elements of the FAIR principles, since they are made at a standard format and allows all FAIR agile elements to be applied. So they're important since it allows easier agile data sharing to your colleagues and collaborators, and many journals and funding bodies now have endorsed the FAIR principles to guide the data sharing. So you're not forced to use CDEs, at least at the moment, but doing so will have a number of benefits that will hopefully begin to clarify in these talks and throughout the afternoon. But ultimately, it should become clearer as you actually progress through the exercises in the workshop that Jean and others have actually set up, that it really is a benefit. So of all the so that's what I want to say on that. This was you, Janelle. This was you. That's fine. Yeah.
I guess hand off. Sorry about that. Just a couple things as we get into it, because you'll need some of this information just as you move forward or do these exercises. So we are so the CDEs make up what's the data dictionary. So there will be a data dictionary. We have up on the PRECISE website, we do have data dictionaries there. Right now they're split up into different kind of groupings like behavior, animal models. They are not complete. They are evolving, and we will be, updating and adding to them relatively soon, in fact. But the way, if we want to envision it, there's going to be one data dictionary. And this will be on the PRECISE website, and this will also be at the NLM, the National Library of Medicine website, under their Common Data Elements portal. But we want to have, for your study, you would have your study specific data dictionary, right? So you would want to go into this data dictionary and pull out data elements that corresponded to your study design. And ideally, you'd want to do this, or encourage your trainees to do this ahead of time, right? And then that would be kind of the perspective version of it. You could also take existing data and then pull down data elements and then map your data to those data elements. Okay, so that's a lot of what we're doing right now in PRECISE, is doing these mapping exercises with existing data sets. And then so here in this example, I know you probably can't read it, but hopefully when you download the slides, you can see it there. But we're putting the data into what we call a tidy format. And so there's basically the data elements, just to orient you to this. So you have this is animal ID. So each data sheet would have these anchors: animal ID and elapsed time after injury. So basically day 0 is injury day. And then at the column headers in this little image of a spreadsheet would be the data elements. So just with the data elements, and when they're in a data dictionary, you have the data element, all of the attributes and permissible values and things like that go with that data element in the data dictionary. So each data element in a data dictionary has its own row, but when you're entering the data, you take your select data elements, and they're at the top of the columns here. So and we're going to practice doing that in a little bit. So why do we need this? I think that probably this is going to sound familiar even within your own lab, never mind sharing between labs, but that, just take age. And this is actually based on some data mapping that Abel Torres Espen did, where he looked at data sets, and these are some examples of how people put age into their records, right? So it's, if you were trying to have a computer, find all these things, sure, you could probably, train it to find the word age, but they're all different formats, different spacings and things like that. So even if you might find this, you go back to your labs after neurotrauma and ask to see some of the data sheets, and maybe look at some from a couple years ago and see what variables that your lab used, because it'll be very eye-opening. Or if not, that's great. If you are one that has some of these things already set in the lab, I don't mean to say that you all might not, but okay. And so this is you.
So CDEs are, so this is about the how and who's doing it. So CDEs are intended to be dynamic and essentially will change and evolve over time, over years, as to keep track of the progress of science. So the PRECISE team will establish or has established a minimum core set of CDEs. Really, those that are the critical ones that are abstract level, that are important to be able to understand a study, so that you can decide whether you want to download that data to pool it with other data. PRECISE is agnostic to the study. We're informed by the funding bodies to develop these. We don't have any ADRI goals in mind. Each study. And so of all the CDEs that are present in the master list, let's say, of course, you don't have to go out and map to all those. You create your own study-specific ADRI data dictionary that maps to your experimental ADRI design, and there will be tools for you to do that that will enable that process to go pretty easily. So all behind PRECISE-TBI is a great team of IT specialists, and they are charged with trying to make that process pretty seamless. So that's the idea. So to ease the burden really on the PI. So you're probably wondering, do I have to share all of my data? And it's really up to you. There are 3 levels of CDEs. The core ones which are talking about the abstract level that define the major parameters, such as the H species, strain, etc. And the recommended, so other variables that are commonly published that we and the whole field, because of course all the other people actually behind PRECISE are volunteers that give their time to help to develop these CDEs, and then we get buy-in from the field when we put it on the website to determine whether or not the field agrees with that. So we aren't making the decisions. And then finally, supplemental variables that are not considered actually critical to the study, but are nonetheless important for defining some of the other aspects. So, so the big picture, what's the payoff? And just think about how having a common language between us all for data management strategy will help to facilitate the multi-PI and multi-site ADRI projects. Over time, the reproducibility among labs will inherently improve, as well as the potential to collaborate, or someone in the field who wants to simply replicate your study would be able to, by pulling down these actual data and the CDEs that define the data. And finally, our CDE will interface directly with the Open Data Commons, which is a data repository that you'll hear more about this afternoon, to be able to store some of your actual data. Ultimately, it would helping you as a lab to adhere to the FAIR principles and the new guidelines that are mandated by our funding agencies. So implementation, it's investment in your lab and your trainees, and of course, it's the mandatory data sharing is on the horizon. Team science is no longer a trendy term, but it is here. And we all know that the actual benefit of tearing down the silos and collaborating. So overall, we as a team aim to actually provide tools that make easier to share data, and all your data sets should get a unique and citable DOI. So that's the carrot, is that as well as being able to publish your paper, your data will be readily citable, and there will be some examples of that this afternoon as well. Other benefits include the actual documentation of negative and unpublishable observations. So some data management issues. So we begin with the retrospective use of CDs. That is mapping existing data to a CDE format, and that's what this workshop is about. But if you think down the line, the future, there's a potential to actually prospectively use CDs. That is to prior to starting your study, to pull down the CDEs, to collect data into that CDE format so that you'll be ready to share that data or directly. That's the potential, but I would like to bring in the caveat that that's all actually well and good, but there comes a time that one does pilot studies, one does discovery science, so it presumably will be limited to standard actual data capture to some degree at least. And that the actual prospective use would not immediately be useful for novel techniques and technologies. So just to finish off this one more thing to talk about is the development of a data management workflow. You've all seen the actual DMS plans that we have to now include in our grants. So before embarking on the design of a data workflow for an experiment, spending some time actually compiling information that could exist in your field should be considered. So, assuming there is prior written actual data management and sharing plan, as shown here, some of the details could be that the CDs could already be available. So why not capture into that format, as I was saying before? Our actually colleagues today and tomorrow will show you how easy the data format is to do graph and to run stats on it, and of course to share the data. So you should look also for open data repositories such as ODC-TBI and SCI to house your actual data that once it's formed, but also for raw data such as imaging and eFIS. There are open actual data avenues to share that data as well. And of course, you should plan any actual budget for doing this should be covered by the grant funding, and you will generate a system for a unique identification of each animal, and really establish a system of electronic storage for your data and for the SOPs that we use to acquire that. So in the last 3 slides, I just want to share a personal note in our lab. So about a year and a half ago, I started a very intensive collaboration. So this is within this notion, and you can see here that has a whole level of articles for which to share data. So the students all have access to this, and this is a real-time tool for the students to input data as it's being acquired, and this is just one level. And I just wanted to say that this type of thing is very amenable to being able to pass it for CTEs. So you can see that in the future we could build this out, so the data automatically drops out in a CDE format. So there's a actual top level experimental, and then there's a lab workflow by Agile Technique, eFIS, Boozy Imaging, and then finally the top level by animals. And of course, all of the parameters can be changed, and the actual viewing can be changed. We have 146 actual variables, and so you can change all that view all dynamically, and it updates on your phone, on your laptop, wherever you are. So it's actually very useful. All right, I'll stop there, I think.